Hello everyone. Today's topic is about CPU, Central Processing Unit. Central Processing Unit, we all know that is the brain, the director, and the decision making of our computer world, right? And in this, there will be steps for executions like fetch, decode, and execute in CPU. We will be explaining this in very easy and cinematic explanation. Absolutely. So, this is one of the most beautiful and cinematic parts of computer architecture. Like, what are those? Those are like fetch, decode, execute, cycle. It's a heartbeat of every CPU, from your laptop to AMD SOC 15 chip. Like, make it super easy and visually cinematic, like a sci-fi movie where your CPU is alive and thinking. So first, the CPU city wakes up. Like, the CPU is like a tiny robot brain sitting in the middle of your SOC city. Its job is to read, understand, and execute commands millions of times per second. Every action it takes, typing a key, opening a file, or turning on a light, starts with these three-step cycles, right? So the three steps are fetch, decode, and execute. So let's take inside the CPU and watch it happen, right? So there is a script, like we'll be imagining this like a script. So the first instruction is like load R1 0x1000. So here what happens is we are loading data from memory into the register R1. Okay, and next we are adding 1 to R1. Okay, and here we are storing R1 back to memory. R1 data back to memory. It's like a movie script written in machine language. The CPU reads it line by line, scene by scene. Okay, and coming to the fetch, reading the script. Okay, so here we are coming to the fetch unit. So, and the main role here is like program counter. A golden beam shoots from the CPU memory. The memory vault opens and hands over an instruction core, like binary code. The CPU proudly holds it up. Instruction fetched. Okay, instruction fetched. And in simple terms, the program counter points to the next instruction here, and the CPU fetches that instruction from memory. Then the PC increments to point to the next instruction. Example, tiny pseudocode, instruction is equal to memory of PC, PC is equal to PC plus 1. Program counter will keep incrementing. And decode. Decode in the sense, in one word to say, it will converts the code into the CPU understandable format. Okay, the CPU unrolls a binary scroll. For example, it's like 100. When the CPU looks this code, it feels like it's a poetry for the CPU. Okay, inside a group of logic gates and circuits, like little interpreters, decode the binary into meaning. Oh, this is an add instruction. It will understand these 100s into an add instructions, and it will add R1 and R2 and store result in R1, right? And in simple terms, we can say that we can further split into the parts like opcode, register, and constants. The CPU figures out what operation to do, and the control unit sends signals to the other parts like ALUs, registers, memories to prepare for the action. Like instruction is equal to 0001, operation is equal to add. Source 1 is register 1 and source 2 is register 2. Okay, and the decoder will sparks fly as circuit lights up, and it will prepare ALU for the add operation. It will load registers R1 and R2. Okay, and scene 5 is to execute, doing the action. Now we enter the powerhouse, that is ALU. It's like a fork of the CPU, glowing, humming, doing math at the speed of the light. The ALU takes the decoded instructions and executes it. If it's add, it will add numbers. If it's load, it fetches from the memory. If it is store, it writes back. Result is equal to register 1 plus register 2. Register of R1 is equal to result. So sparks flash as two numbers, merge into one new orb. The result, the CPU smiles. The task is completed. As soon as one instruction finish, the camera pans back and the CPU immediately fetches the next one. Like here, the flow is like it will fetch, decode, execute, and fetch, decode, execute. It loops endlessly, billions of times per second, a heartbeat that never stops. Every app, every button, every video you watch, all powered by this loop. Inside SOC 15, the advanced version, in AMD SOC 15 environment, the cycle happens in multiple Gen CPU cores simultaneously. Each core has front-end, a scheduled and ALU out-of-order execution. It's like having a team of robotic workers, each fetching, decoding, and executing tasks in parallel, while the Infinity Fabric Highway keeps them all synchronized. So instead of one light pulsing at a time, imagine thousands, a neural network of glowing circuits, all dancing in perfect rhythm. Thank you. If you found this video helpful, please subscribe.